Standard deviation is a measure of dispersion of values. It indicates variance from the mean value and is represented by the Greek symbol sigma. Standard deviation is the square root of variance. The formula to calculate standard deviation S for a sample is square root of the sum total of x minus x over bar the whole to the power of 2 divided by n minus 1, where x is a value in the data distribution, x over bar is the mean of the sample given, and n represents the total number of observations. Whereas the formula to calculate standard deviation for a population is square root of the sum total of x minus mu the whole to the power of 2 divided by capital N, where x is a value in the data distribution, mu is the population mean, and capital N for the total number of observations. The symbol of the standard deviation of a random variable is the Greek symbol sigma, whereas as a symbol for a sample is the letter S. In this illustration, you see that the mean at the center where the maximum number of observations stands. For example, general height of a population, say if it's 5 feet 5 inches, it would be here in the middle. The deviation from this would mean to the right side it's a positive deviation, and that could go 5.6, 5.8 inches, and an exception of even 6 feet 2 inches towards the right extreme. Similarly, to the left we see a deviation which is considered as a negative. If 5.5 is the average mean height, towards the left you would see it decreasing from 5.4, 5.3, 4 to 4 feet 11 inches, and even 4 feet towards the left extreme where you see 0.1%. This is how you read a distribution across a bell curve and make a note of standard deviation, be it positive or negative. Let's take an example. The number of observation and frequency are given below. 6, 10, 12, 14 and 24 are the 5 observations. The frequency is 2, 3, 4, 5 and 4. Let's apply the formula and find out the standard deviation. In this case, we need to draw a table and find out the variance, which is sigma square, and then take its square root. To the left side of the table with the header A, we have the number of observations copied vertically, and with the header B, we have the corresponding frequencies. We need to multiply A and B to get the frequency multiplied by observations. You get column C. The fourth column is titled D, and we have the mean calculated by adding up the number of observations and dividing it by 5 to get 10. Column E is derived by subtracting D from A. You see that the first column minus column D will give minus 4, minus 2, 0, 2 and 4. Column F will give us number of observations minus the mean to the power of 2, which means we need to get the square of column E. We now get the answer as 16, 4, 0, 4 and 16. That is a square output. The last column is derived by multiplying column F with the number of frequency, which is column B, and we get 32, 12, 0, 20 and 64. The sum of 32 plus 12 plus 0 plus 20 plus 64 will give 128. From what is given, we could calculate the variance. Sigma square is equal to 1 divided by capital N multiplied by sum total of frequency multiplied by number of observations minus mean to the power of 2. Capital N is derived by adding the frequency in column B, which is 2 plus 3 plus 4 plus 5 plus 4 to get 18. 1 divided by 18 multiplied by 128 is 7.1. 7.1 is a variance, which is sigma square. We need to arrive at the standard deviation, and square root of variance is standard deviation. Let's take the square root of 7.1 and we get 2.66, which is the answer.